Hello guys, KNOCKCAT this side. So today we are going to solve today's GFG problem, and the problem is linked list that is sorted alternatingly. So it says you are given a linked list of size n. The list is in alternating ascending and descending order, and sort the given list in non-descending order. So I hope you have already read the problem and at least try it by yourself. So if not, I will strongly suggest go and read and at least give it a try. So the problem is in a way that we are given a linked list, and that list is we can say sorted alternatively. That means we have list as ascending, descending, ascending, descending. So if I took these nodes, these are sorted in descending order. And if I take these nodes, these are sorted in ascending order. So let's come to the whiteboard and take this same example. So as I was mentioning, this is like ascending, this is descending, this is again ascending, this is descending, and this is again ascending, and this is descending. So if you tend to observe this, if I segregate ascending nodes, so it is actually 1, 2, 3. And if I segregate descending nodes, these are 9, 8, 7. And now look to the problem. What problem says that we need to return the list in complete ascending order. That means we need to return 1, 2, 3, 7, 8, 9. So can you observe something? 1, 2, 3 part is fine. We need to return 1, 2, 3, 7, 8, 9. Can you observe something? 1, 2, 3 part is clearly fine. Like if I segregate these ascending nodes, 1, 2, 3 parts is completely fine, and 9, 8, 7 is completely fine if I reverse this. So I would be getting 7, 8, 9. So this is also fine then. If I put out all the ascending nodes and then I put all the descending nodes simultaneously, you will actually find that 1, 2, 3 is already fine as we need, but 9, 8, 7 is in this descending order, and that we need in ascending order. So since it is already sorted in descending order, if we just reverse that part, we will actually get 7, 8, 9. And then we just join these two nodes. So that's why it's become very important to at least write the test case in your notebook or at least in a drawing board so that you can figure out these observations. So now if you get to understand how you will achieve this, you can pause this video and can do things on your own. So this is something. So now we know we need this, we need this. So how I will do this? Let's come to the intuitive. The intuition is similarly that these are odd nodes, these are these are even nodes, these are even nodes. Put all even nodes together and put all odd nodes together. And after the end, join even after odd. So just this thing we have to maintain. So for this, I have already have kept the code here so that I can explain you with the help of this one. And simultaneously I will do the driving. So we have this list. I have made two pointers. I have made two pointers, which is actually two dummy nodes, ascending and descending. Okay. And we have ascending and descending. So we have 0 here and we have 0 here. And the name to it is ascending and the name it is to it descending. After that, what I did, I have a pointer. These are my we can say fixed pointers, and these are moving pointers to which I will move, ascending pointer and descending pointer. So currently my ascending pointer is also pointing to here, and my descending pointer is also pointing to descending. Now I have taken a variable flag which will help me to figure out which is the even position and which is the odd position. Before I go with flag, we know if I do 1 XOR 1, same bits will always give you 0, and if I do 0 and 1, then it will already give me. So if I do my flag XOR 1, I will get 0, and if I do my flag XOR 1, and if flag was 0, I got 1. So by this, I can actually say if it was 0, I am at odd even positions, and if it is 1, I'm at odd positions. So I think this is no need of worry. You can also use, instead of this, you can also use that if I mod 2 is equals to 0, then do this part, and if it is odd part, then do this part. That's it. So now, if flag, that is, I am looking at this flag is actually looking for it as an starting, it is true. So it will looking for odd nodes. So if it is true, then take this one. Temp was actually pointing here. Temp is pointing to here, and I have made node star is equals to star of head. Okay, this I forget. We are given with star head. That means a pointer to pointer. Star head is actually a pointer. Star head is actually a pointer to my list of starting node, and we are given star head. That means there is another pointer which is holding an address of a pointer. So star head in itself is a pointer, and it's a star head. That means it is the address to that pointer, which is actually storing star head. That if you know that if I take star p is equals to a, and let's say a was some value, then star p is a pointer to a. So let's say here p is a pointer to my node and this pointer. So if I do star p, that means I have address of this pointer. I have address of this pointer, but we know we need the value of that node. That's why we do a one level of dereferencing and we took star p. We are given pointer to pointer. Okay, we are given pointer. We know head is already a pointer, and we given an address to the pointer of address of this pointer. Star head is already a pointer, and this address is also stored in a pointer, and that's why it's two level of difference. But since we only need this star head, that's why we said okay, we are given this. This is actually storing address of star head, but I need star head, so we do a one level of dereferencing. So that's why we get star head. We, if you have no pointers, you know pointer is actually star p. So if I know p is actually the address, if I know the value, we do star p. So star p, I need the value at this. So star p will give star p was the address, but star p will give me the value of this internally. So this is one level of dereferencing here. So that's why just you make you clear. So we know instead of giving star head, I give star head because I don't need the address to that node, but I need that node itself. So temp, and I have assigned to temp. So temp is actually at starting here. Now flag part, that means I am already here. Ascending next would be temp. Ascending next. So ascending was my moving pointer, and I am saying ascending next would be temp. So ascending next, it's here. Ascending next will now become temp, which is 1, 9, 2, 8, 3, 7. The list will look like this. Ascending pointer to ascending next. Next time, my ascending pointer is actually here, 1. Now else part. Okay. Before coming to temp will become temp next. So temp will now point to here. Temp will now point to here. So let's make temp as here, and let me erase this so that there is no bit of confusion. Flag XOR 1. Flag was initially 1. 1 XOR 1 would be 0. That means next time this condition will run. So I have, let's say now I'm at odd position index. I'm at 9. And now it will say descending pointer next will become 10. Descending pointer is here. Its next will become temp. Temp was actually at 9. So 9, 2, 8, 3, 7. We got all these. Okay. And now it is saying move your pointer descending pointer to descending pointer next. So now my DSP is pointing to here. These are moving pointers. Okay. Next time temp, this time temp is 0, 0 or 1 is 1. So this condition will run, and temp is pointing to temp next. Temp is now pointing to here. Let me erase these. Okay. Temp is pointing to here, and this condition will run. Now it will say ascending pointer next would be temp. Ascending pointer is pointing to 1. 1 next would be temp. 1 next would be 2. That means 1 next will now contain 2. 1 next will now contain 2. And ascending pointer will come to next. Now it is pointing to here. Similarly, next time I'm not running this now. Next time temp will point to here. Okay. Descending part will run, and it will say descending pointer next would be temp. So temp is actually at 8, descending pointer is at 9, descending pointer next would be 8. So this is the condition, this is now, and now my pointer is at here. Next time this part will run, so it will say, and my temp is moved to here, my temp is moved to here. Now it would say ascending part next is temp. So I was at 2, it says 2 next was 3, temp is here, 2's next was, 2's next would be, 2's next would be 3. So that's it, we have now this, and my pointer will now come here. Next time temp, this condition will run, temp is now pointing to here, this would be the case, temp is pointing here, descending part will run, and it will say, okay, 8 next. 8 next would be my temp. Temp is pointing to 7, that means it is doing like this. And now I have 7 here. And this pointer will move to here. This pointer will move to here. To list has been segregated. Now this part has done. To list has been segregated. We can say this as ascending list. We can say marker. This is ascending list. And we can say this is descending list. But now I need this descending list and ascending list. So I actually need to reverse this. So I call a function called reverse or descending next. So what will I get after this? And I sent descending next. That means this 0 will not. I said descending was the static pointer, and descending was the static pointer, and these are the moving pointers. These ascending and descending pointer were the moving pointers. These are static pointers. Okay. So now that means 0 was not came, and I sent 9, 8, 7 as a list. And we know when reverse logic will run, it will return me 7, 8, and 9. Okay, 7, 8, and 9. So, and like now, if you look carefully, I have already at the end of my this list, 7 was actually here. 7 was actually here. 7 was already here. And this list will return like this. We have 7 here also. And this list will return 7, 8, 9 in reverse order. 7, 8, 9. At the end of 3, we have already 7. So when this reverse list came, we also have 7, 8, 9 as here. So, and my head was initially pointing to here only. Why? My head was pointing to here only. Head was actually pointing to temp, like head was pointing to initially at 1 only. Okay. We make 0 pointer, but it's for our reference. But if you look carefully, head is actually pointing to 1 only. Like our temp or head is pointing to here only. Temp moved to here simultaneously, but head is pointing to here only. So if I have to say, head actually contain, after this, head actually contain 1, 2, 3, and when this reverse part came, 3 actually containing 7. But when this reverse part happened, 7 also added 7, 8, 9 within itself. So 7, 8, 9. So our job is done, and this is the whole complete logic that we need to do. This might feel confusing why there is 7. That's why I show you the diagram that we know 7 is here, and when this reverse part will be here, it will actually append this one, because initially my this list contains 7, 8, 9. My this list contains 7, 8, 9, and reversing will be 7, 8, 9 as this. After 7 was nothing, but when 7, after 7 there was null. But when 7 was reversed, 7 has 8 and 9 in this order, and that's why 7, 8, and 9 will append it like this. And since my head is pointing to here only, my job is done. Now, some might be thinking why this case already works, that 7 will left here always. The reason is quite simple. I also think of this. So I come with a proof why this will always work, because we will always be having even number of nodes. We will always having even number of nodes because we have ascending, descending, ascending, descending. We all have always even number of nodes. We all have always even number of nodes. So the last time when I was an even will be running first. So when the last time I was at ascending node, it will also keep descending node with itself. Always. It will be the case always because my list contain even number of nodes. And that's why when I was accessing the last even node, sorry, the last ascending node, so it has 7 to it. And when we do descending, 7 put in things in reverse order, and we will actually get 7, 8, 9. So that's why it's working, because we have even number of nodes, and last ascending will always keep descending. And since the logic is reverse, now descending earlier not containing anything, but after this reverse part, it is containing 7, 8, and 9. So this is how we get to solve this problem. Now let's come to the reverse of the. I assume most of you know how to reverse a linked list, but if someone don't know, let me take this also. So we know the list was that was sent the list that was sent was 987. So I will take this example only. So we have 9, 8, and 7. Okay. What we did, I make a previous pointer. Let's take a previous pointer that is actually pointing to null. When I came to head, my head is actually pointing. My head is actually pointing to here. Okay. And when I say head next pointer will contain heads next. So head next is actually 8. So let's take next pointer also, and it is actually containing 8. What I did, I said head next, make head next split. Since we have to reverse the list, so I said head is here, make head next as null. So 9 nines next have become null. You might be saying, why null? Head next become priv was actually null. So 9 next have become null. I said now make my previous head. Priv was 9, now make my previous head. 9 will become my priv, because next time 8, after 8 I have to put 9. So priv was, now my priv will be updated to 9. Okay. And head will become to next, since I have to come here also. I have, after processing this node, I have to come here also. So now my head is pointing to here. On the next iteration, next will contain head next. So this time it will contain 7. It will say head next will now become to priv. We have 8. 8 next will now become to priv. 8 next will now become to priv. 8 next priv was 9. Now I update my priv to head. It will become 7. And head will become to next. Head will become to next. So this time my head is here. Now next will say head next. We don't have any next. So now next will contain null. Now it will say head next will now become priv. Head was at 7. 7 next will become priv. Priv is actually, okay, it was 8 actually. Okay. Priv was actually 8. So head next. 7 next will now become priv. That was 8. And head is equal to next. Next time my head will become next. My head will point to null. So the job is done, and we are priv. Priv is actually, before that priv will become head. Head was at 7. Priv will become 7, and now my head is at, my priv is actually pointing to here, and I'm returning priv. So 7, 8, 9. This is the return list that we got from here. And since my 7 was already here, and it has to be, because after every ascending node there would be a descending node, because we have even number of nodes, and that's why after just we put the reverse, our job is done. So let's come to the code. That is exactly the same. I will retrieve, like, I tried various approaches, and I was trying from them also. This what. So reverse part, 2 pointer ascending and descending. Yeah, these are static pointers, and this is fixed pointer. Sorry, these are moving pointers. So flag logic for even nodes, for odd nodes. And after all these nodes have been segregated, reverse, if I do reverse, I do not need to append after ascending the descending part. Why? Because the last node is already containing that 7, and that 7 will then join the descending list to it. So that's it. If you run this will work fine. Since I have got many permissions, let's put one more. So yeah, so that was 7. So that's it to this problem. And I will say here this question works because we have even and odd list segregated. If the list was in any random order, do visit or do solve a problem called sort list. It is on lead code. It might be on GFG also. And that is, let me give you a hint. This is solved using merge sort plus we have a pointer, we have a fast and slow pointer that is known as turtle hare algorithm. So sort list. And the time complexity of this code is order of n only for reverse also and for the segregating also. Space complexity, you can say order of 2 because we have used 2 dummy nodes, but let's say since it is constant only, so it is constant. So if I had to write the time complexity, so it is order of n, and the space complexity is order of 1. So that's it. So after this problem, please solve the problem shortlist and you will good to go. So thank you and not get this.